Hey guys, welcome back to Engineering Education. For this next problem, we are asked to convert 345 octal to binary. And we're given four choices here. It's a multiple choice question. So pause the video, try to solve it on your own, and we'll go over it in a bit. So, like I've said in previous videos, the best way of solving this is to use the calculator in the description. That will handle this, very easily. It has a mode for dealing with binary to octal to decimal to hexadecimal conversions. So, if you have that calculator, plug in 345 in octal. Press the binary key and, get the answer in 15 seconds. For those that don't have the calculator, we'll do it out by hand. And the way you can go about doing this is converting from octal first to decimal, and then from decimal over to binary. There is a way to go from octal directly to binary, but I recommend doing it this way. I mean, it does take some time, but if you're careful, you can get the right answer here. So we're given 345. I'm going to change colors here to green. 345, 8, which is octal, and we want to convert it to something in decimal. Okay, and the way we did it in the last video, we took the 345 and then we put the base digits on the bottom here, 8 to the 0, 8 to the 1, and 8 to the 2. And then we just did the product sum of these. So in order to get the decimal, it would be 3 times 8 to the 2 plus 4 times 8 to the 1 plus 5 times 8 to the 0. And when you do that, you get 229. So that tells us that 345 octal is equal to 229 decimal. So this is decimal. Okay, and now that we have it in decimal, we want to convert 229.10 to something in binary. And to do that, it's a little trickier, but still doable. And the way I usually do it, because I tend to get confused a lot, is I write down the powers of 2, starting from the right over to the left. So 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. And so this is 2 to the 0 is 1, 2 to the 1 is 2, 4, 8, 16, and then we'll keep going up until we get to 229, 2 to the 6, 2 to 7. Okay, so that'd be 16, 32, 64, 128, 256, and then we can stop there because 256 is larger than 229. And so we can separate these out. Change colors again. And then we're going to take this 229 and see how many times it fits into 256. And it fits in 0 times. And we move on to the next one. So 229, does 128 fit into 229? And yeah, it fits in once, right? And so now we would take 229 and then we would subtract 128 from it. Okay, so that'd be, let's see, I'm going to write it up here. 229 minus 128 gives us 101. Okay, so now we have 101. So does 64 go into 101? Yes. Okay, so then same process, 101 minus 64 minus 64 gives us 37. Does 32 go into 37? Yes, it does. So you subtract 32 here, get 5. Does 16 go into 5? No, it doesn't. Does 8 go into 5? No, it doesn't. Does 4 go into 5? Yes, it does. Subtract 4, and we're left with 1. Does 2 go into 1? No, it doesn't. 1 does go into 1, and we put a 1 down there. And so we can partition this a bit, and we get the binary equivalent is 0111 00101. Oh, well, hold on. We can drop this last 0 here and then just partition it like this. So it's 111 00101, which would be, I believe, D here. So that is the answer to that problem. As you can see, it takes a while to do it by hand. So again, I recommend using the calculator in the description to save you some time. I mean, you only have 5 to 6 minutes per problem, so if the calculator can handle it for you, then I definitely recommend going that route. So, did you guys get that? Leave me a comment in the box below, and until then, enjoy engineering.